that here T flip-flop? So here we could see the representation of the T flip-flop. That is the timing diagram of the T flip-flop, right? So here I have considered positive edge trigger. In this case, we have considered the positive edge trigger. So you could observe during the positive triggering nature, then there exhibits the output value here. So this is what the clock is. You know, clock consists of both positive edge, positive clock cycle as well. The negative clock pulse will also be there. So that's why it's been mentioned here. Clock has been mentioned as positive as well negative. Here I have mentioned. Then for the case of T flip-flop, you know very well the value of the T input. This is what I'm going to apply. So this also be my own logic. So if I provide the input value as T, so this is how I'm applying the input value. So during certain time, I'm just applying it as 1, and I'm making it as 0 for a certain long duration. Then again making it as 1. Likewise, I make this move. But depends upon this clock pulse and the T input case, I'm going to receive the output value. That is what the clock output value here. This is I'm considering. So now let's see. For the positive edge triggering only, it will act, right? So this is what it is. It suggests, the clock pulse suggests. So during this portion only, whatever the value that is going to reflect, output value is going to reflect at this specific location. So you could observe during this positive edge triggering, during this pulse, what happens at this T flip-flop? It lies in a one value, right? It lies in one value. That's why it will start to become 1. From this location, it starts to emerge as a value of 1. That yeah, how the output value of Q has become 1? Yes or no? Basil, Darshni, Uday Kumar, Binay. Am I audible?
Yes, ma'am. Yes, ma'am.
Okay, thank you. So now this is how it will look like. So for the case of applying the positive edge triggered at this location, your output value will start to emerge. So it depends upon the input value you have applied. Right, then it keep on till this phase, there will not be any changes you could experience in the output side, since only since we are applying the positive edge triggered value. So during that specific location only it may alter, right? Till then there will not be any changes, right? So this is where we are receiving the value. But again, here at this specific location, it may start to alter. So here, if you consider at this specific location, what would be the value of your output? So that's what you need to consider. But at this location, it's your input value is in the position of 0. But you know very well, each combinational circuit has some propagation delay. This and all you might have studied in your carry adder and all, right? So there will be some propagation delay. So in order to transfer the information from this location, this AND gate has some delay, and this OR gate AND gate has some delay, this has some delay, this has some delay. So due to that specific time, it will not, that is the output value will not reflect immediately. Since it's at the initial condition, it has got reflected immediately, but at this location your information is getting processed, so it could not there will not be any immediate reflection at the output value. There will be some delay. So since that delay has been carried out over a long time, it is being not reflected. So till the next phase, it starts to lie in the same portion only. But again, during the next positive clock trigger, so next positive edge clock triggering, what happens? Purely it suggests it's in a positive pulse, but previously again due to the application of the propagation delay here, it will not immediately reflect that, you know very well, right? So that's why whatever the thing which has been appeared in the previous pulse, that's been reflected here due to the propagation delay. This and all you might have studied in the second unit, combinational circuits, right? So the propagation delay concept and all you might have studied. So that will result in the delay, and you might have uh, received some previous pulse information. Then finally, again, you have received some positive edge trigger, but it again you could sense the information as positive, but it's not the reflection of this exact T input value. This is nothing but the reflection of this respective T input value. Since there exists some propagation delay, here this will get reflected at this location. Likewise, for the immediate pulse, for the initial stage, it will be reflected immediately. That is input value, and the clock has been synced with, then obviously you will receive the same output value. But after some time, since the internal circuitry of the T flip-flop consists of more circuits, so it has some propagation delay. Everywhere it has some propagation delay. That delay will reflect on the output value. Is that clear? Yes or no?
Yes, ma'am.
Okay. Shall I, yes, next I'll move on to the JK flip-flop. So here, again, JK, these are the two input bits I'm going to utilize for making output value. So I'm going to consider J and K or the two input values, right? So again, the internal circuitry will be differ, whereas when you consider the T flip-flop, here somewhat different. So, but instead of instead of using a single input value at the T flip-flop, here we are considering two different input values. Every other thing and all same. Say the circuitry arrangement and all same. If you consider keenly, the circuitry arrangement and all same here. If you just observe closely, the same circuit arrangement. So two AND gates. One of the inputs for this AND gate is from the Q complement only, right? So at this location, you are receiving the value. Likewise, Q is being provided as a feedback value to the one of the other AND gates. It's same condition exists here too. So one of your input value, output value has been given as well. One of your input value has been given, but instead of connecting the input value from the output of the NOT gate, one has been connected directly and the other has been taken as a output of the NOT gate. That's what the only difference between these two is. Every other thing and all same only, right? So here we are not considering on the output of NOT gates. So the expression for writing this entire thing will look like this: J Q complement plus what? K complement Q. This is similar to that of your previous expression only, but there we had used the term for both J and K as T, right? Only a single input we have used. That's why we have written it as T. But here we are using two different inputs. Every other concept and all same only, but only difference is we are going to use two different inputs, right? So one is J and the other one is K. That's it. Okay, so every other thing and all same. So here I will see the same circuitry. We are going to look into the same circuitry only, but the excitation table will differ since we are providing two different inputs, J and K as inputs. So 0 0 0 1 1 0 1 1. These are the two inputs we have. So for this thing, you know very well, if you apply both the input value as 0, what would be the thing? It will lie in the current state only. This is what we have seen in the T flip-flop, right? So that's same as the of that one. So it will lie in the same state. But if you provide the value again, if both of your input value has been 1 1, it's quite similar to that of T only. It's nothing but the toggle value of your current state. Here you could experience the toggle nature of the current state value, that is Q complement T, right? So this is what it is. But now, if you apply the value of 0 for the case of J, but for the K flip-flop, the value gets 1, what would be the output value? It will rely on the output value as J only. Whichever the value being applied at the J, that is reflected at the current state value. Can you observe this? Here, for this input value, this is quite similar to that of the previous T flip-flop only, that is current state value. Then if it's toggled, whatever the input value, if that gets toggled, obviously that reverses the current state value. So since it's Q of T, here we have received Q complement of T, the reversal of your current state value. But now for these two cases, one of your input value being inversed. So one of your inputs is 0, then other input value being 1. So this is what the expression is. But the output value, that is the current state value, represents what? Whatever the input value of J, that is getting reflected at the output value. Is that clear? If you apply the value over this expression, you would receive the same output value across this junction. So let's see. Initially, if I apply 0, 0, for this case, if I apply 0, 0, what would be the output value? Let's see. So initially, if I apply 0, 0, what you would receive across this? Here, it would be 1. So if it's 0, any one of your inputs of AND gate is 0, obviously you will receive 0 only. Then here, depends upon the clock value. So let me consider the clock value is 1 across this juncture. So then it would provide you the value of what? 1 only. So any one of your result will become 1. So D flip-flop will provide you the same value, that is what? 1. Right, so whatever the input value you may receive. So let me consider, since I have considered the current state value across this location is 1. Right, so I have considered the current state value as 1. So it relies on the fact of what? Same current state value only. That's why it shows 1 value. So QT represents what? Whatever the current state value I have received, it will lie on the same condition. That's why it is. Then, if I changed the input value of K as 1, now I have changed the K value as 1. So this will reflect the same value since one of my inputs to the AND gate is 0. So it will reflect the same value 0 only. But at this juncture, what would happen? Since I am providing out K value as 1, it will reflect on 0. So one of my inputs now becomes 0, right? So it lies in the same current state only. I'm taking the feedback value at this juncture. Since it's 1, I'm just maintaining it as 1. But what happened? My K value, since it become 1, my one of my inputs to the AND gate has become 0 at this juncture. So again, this will result in what? 0. So you know very well, 0 or with 0 will result in what? 0 only. So if your input to the D flip-flop is 0, you will receive 0 as an output. Then you just reverse the input values. Previously we had used it as 0. Now I'm just going to reverse the value as 1 at this juncture. I'm just going to make this K value as 0 here. So if I make this value as 0, it would become 1. And if I make this value as 1, this value will become 1 at this juncture. So here it will become 1. Now this condition, it will become 1. Now, you know very well, if the previous case consists of the current state value has become 0, then obviously the reversal state would become 1 only na, for this case. If it's 0, this will become 1. So here we have received 1 value. So 1 and 1 will result in 1 at this location. Since it's an AND gate, we will receive the value as 1 across this junction. So here we have received it as 0. So again the value will become 0. So any one of your input value has become 1 for the case of OR gate will result in 1 only. So finally you will receive again the 1 as your output value. At this juncture, you have received 1 as an output value. Now, changed the input value of K as 1. Now, you're maintaining the K value as 1. So, every other thing and all same only. Since it is being 1, now it will become 0. Since your current state value is 1, your toggle state, that is reversal to that of your current state, will become 1 on it will become 0. So here 0 will get passed over for this on AND gate. So this will result in 0. Now, since it's 1, you are going to transmit 1. Already, you know, we have changed the K value as 1. So 1 and 1 will become 1 at this location. So 0 or with 1 will result in 1. Yes, So here it will transmit the information as 1, right? So whatever the information you have received, that may get toggled. So since whatever the current state condition which was appeared earlier will get first. So this is how the flip-flop will work like. JK flip-flop will work like. It is quite similar to that of your T flip-flop only, but instead of using a single input across that junction, we are maintaining 2 inputs. That's it. That's the quite difference here. That here, JK flip-flop? Yes or no? Am I audible?
Yes, ma'am, audible.
Abhinav, Nitin, Sevuga Perumal, Syed. I'm not receiving any response from your side. Am I audible?
Yes, ma'am. Yes, audible.
Yes, ரொம்ப நேரம் கழிச்சு வருவா. என்னடா எதுவுமே பதில் சொல்ல மாட்டேங்கிறீங்க.
Yes, ma'am, audible.
Audible ஓகேடா. கான்செப்ட் புரியுதாடா? JK flip flop புரியுதா?
இன்னொரு வாட்டி ரிப்பீட் பண்ணுங்க.
இல்லடா இப்படி சொல்லி இவ்வளவு நேரம் என்னடா பண்ண? Okay. My screen visible? Yes or no?
Yes, ma'am.
Okay. So T flip-flop is similar to the, JK flip-flop is quite similar to that of T flip-flop only. But instead of using single input in T flip-flop, you're going to use 2 different inputs at JK flip-flop. For the case of JK flip-flop, you're going to use 2 inputs. That's it. That's the quite difference we have at this JK. So here we will be providing the input value directly to one of the AND gates, and we will be providing an inverted input value to the one of the not AND gates. This is what the single difference we have at this juncture. Every other thing and all same only. So again, we are using some D flip-flop at this juncture. We will be using some different internal circuitry combination, quite similar to the T flip-flop only. But you know very well, so if you provide 0 as an input value for the case of T flip-flop, you will be receiving the current state value. If that gets toggled, you will be receiving some toggle value, burst value. This is what you might have received. Sorry, you will receive in. That's what it's. So now, since I'm using 2 input cases, 2 inputs I'm going to use. So that's what I'm representing it with 0, 0, 0, 1, 1, 0, 1, 1. So this and all quite similar case. If it's 0, 0, it will rely on the current state only. If it's 1, 1, it will rely on the next state, right? So that's what it is. So only the difference we have is 0, 1 condition and as well in the 1, 0 condition. If I apply for the case of 0, 1, you will receive whatever the input value which is being applied to the J input. That's what your output is. Here, if it's 0, you will receive 0 as output. If it's 1, you will receive 1 as your output. This is what you will receive out of it, right? Okay. Now, so whatever the value we have at this juncture, so that's what you're going to receive for the case of JK flip-flop. So if I again I'm going to use a positive edge triggered. So positive edge triggered will provide you the output value. It will sync the value during the emergence of this this location, right? So during that thing you will receive this. So this is what it is. This is how it will look like. JK flip-flop. Again, every other the timing diagram will look into once you observe that, you may see the information clearly. So now how it will work? Yes, it's similar to that of T flip-flop only. So instead of using a single input and T flip-flop, we are going to use two different inputs. One is J. It can also be used as SR and T flip-flop. It's again versatile combination of your SR and T only it is. So for using J value as 0, as well if you use the S value as 0, it will rely in the current state value. So whatever the state value which is being there, you will receive the same nature of the output value. As you know, in SR flip-flop,